Hello everyone, welcome back to your YouTube channel Mathematics for Everyone. In this video, we shall take very important questions relating to solutions of simultaneous linear equations. First question, if matrix A is equal to 2 minus 3, 5, 2 minus 3, 5, 3, 2 minus 4, then 1, 1 minus 2, find A inverse, find A inverse and and hence solve equations, solve equations 2x minus 3y, 2x minus 3y plus 5z is equal to 11, then 3x plus 2y, 3x plus 2y minus 4z is equal to minus 5, x plus y minus 2z is equal to minus 3. Solution, we have matrix A is equal to 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. First of all, find out determinant A, expanded by first row, 2 into minus 4 plus 4, then plus 3 into minus 6 plus 4, then plus 5 into 3 minus 2 is equal to 0, minus 6 plus 5, which is minus 1, which is not equal to 0. Therefore, A inverse exists. Then we find out cofactors of elements of A. First of all, cofactors of elements of first row, C11 is equal to minus 4 plus 4, minus 4 plus 4 is equal to 0, then C12 is equal to minus 6 plus 4. It is 2. C13 is equal to 3 minus 2, 1. Then C21 is equal to minus elements of second row. This is 6 minus 5. It is minus 1. C22 is equal to C22 minus 4 minus 5 is minus 9. C23 is equal to minus last element of second row. This is 2 plus 3. It is minus 5. Then C31 elements of third row. This is 12 minus 10. 12 minus 10 is 2. C32 is equal to minus second element of third row. This is minus 8 minus 15. Minus 8 minus 8 minus 15. It is 23. Then C33 is last element of third row. It is 4 plus 9 is equal to 13. Then adjoint of A is the transpose of the matrix of cofactors. Adjoint of A is 0 to 1, then minus 1, minus 9, minus 5, 2 minus 23, 13. Transpose is equal to first row will be first column 0 to 1, second row second column minus 1, minus 9, minus 5, third row third column 2 minus 23, 13. Then A inverse is 1 over determinant A into adjoint of A. 1 over minus 1 into 0 minus 1, 2, 2 minus 9 minus 2, 1 minus 5, 13. This will be 0, 1 minus 2, minus 2, 9, 2, minus 1, 5, minus 13. Now we have 2x minus 3y plus 5z is 11. Then 3x plus 2y, 3x plus 2y minus 4z is equal to minus 5. Then x plus y minus 2z is equal to minus 3. We can write it in the matrix form. First of all, coefficient of matrix of coefficients 2 minus 3, 5. Then 3, 2 minus 4. Then 1, 1 minus 2. 1, 1 minus 2 into variable column matrix x, y, z is equal to constant matrix 11 minus 5 minus 3. We can check this with A. The given matrix, first row is same 2 minus 3 minus 5, second is 3 2 minus 4 same, third is 1 1 minus 2 same. So that means it is equivalent to Ax is equal to B. That means x is equal to A inverse B, where A is 2 minus 3 5, 3 2 minus 4, 1 1 minus 2, x is x y z variable column matrix, B is a constant matrix 11 minus 5 minus 3. Substituting values in x is equal to A inverse B. So we have x is a variable column matrix. A inverse is 0, 1 minus 2, then minus 2, 9 minus 23, then minus 1, 5, 13. B is a constant matrix, 11 minus 5 minus 3. Multiplying first row with this column, 0, minus 5 plus 6, then minus 22, minus 45 plus 63, then minus 11, minus 25, minus 11, minus 25, this is minus 13. It will be 39. So this is minus 5, 5, minus 13. So this will give you 1, 2, then this is 3. This will give you x is equal to 1, y is equal to 2, z is equal to 3. This is the answer. We shall take practice question. Question second is a practice question that you will do in the same way as the first practice question. Find the inverse if matrix A is equal to matrix 1 2 5, then 1 minus 1 minus 1, 2 3 minus 1, hence solve equations x plus 2y plus 5z is equal to 10, then x minus y minus z is equal to minus 2, 2x plus 3y, 2x plus 3y minus z is equal to minus 11. You will do it exactly in the same way as we have done the previous question. First of all, we shall find A inverse. Then after that, by using relation x is equal to A inverse B, you will solve this. And the answer for checking will be x is minus 1, y is minus 2, z is 3. So please do it in the same way. That's all. In the next video, we shall take more important questions relating to solution of simultaneous linear equations. So please don't forget to like, share, comment and subscribe to the mathematics for everyone to see more important videos. Thank you. See you in the next video.